Hello students, and welcome to the second video in this lesson. In this video we're going to be using more theorems to solve a question, so let's get started. So you might want to go and grab your calculator before you start this question because we will be using our calculator to find some of the specific values to 3 decimal points. But let's go ahead and read this question. We have some sort of function that is measuring the cost of bottles of Pepsi Cola and is using that function in order to estimate the cost of transportation. So X is the order size and number of bottles of Pepsi Cola in hundreds. Maybe if questions come up with that, we're going to want to make sure we're going to specify those units in hundreds or something like that. Our first question says, is there a guaranteed value of R on the interval from 0 to 3 such that the average rate of change of cost is equal to C prime of R? So let's kind of think about, all right, what does everything need to happen here? So is there a guaranteed value on this interval such that the average rate of change, so the average rate of change, let's kind of just like make a note of that, is equal to the derivative? Well, what kind of theorem uses the average rate of change where it's equal to the derivative? And that you should be thinking of the mean value theorem. All right, so let's kind of go through that. Well, the mean value theorem states that C of 0 minus C of 3, because we're going from 0 to 3, or 0 minus 3. And what I notice here is that C of 0 is going to be undefined because I have 1 over 0 right there, and so it's not going to work out. Since that function's undefined at 0, it is not continuous on the closed interval from 0 to 3. It has to be continuous on the closed interval from 0 to 3 in order for the mean value theorem to guarantee something on that interval. So since C of x is undefined when x equals 0, then C of x is not continuous on 0 to 3. Therefore, the mean value theorem does not guarantee a value on 0 to 3 such that the derivative is equal to the average rate of change. So like I said in the last video, you really just want to make sure that everything is crossed and everything is check marked before you actually dive into the theorems, and assuming everything is true beforehand, okay? So if it doesn't explicitly state it, you do need to find those derivatives if necessary. So now we have our second question, and is there a value of R on the interval from 3 to 6 such that C prime of R equals 0? So give a reason for your answer, and if such a value of R exists, and find that exact value. So again, you want to be thinking, okay, on the interval from 3 to 6 where that derivative equals 0. Again, you can use the mean value theorem, or what this is getting at is Rolle's theorem. Since I used the mean value theorem last time, I'm going to be using Rolle's theorem completely here. So what I want to start with is, okay, I want to find C of x and I want to simplify it. So we're going to have 10,000, and the reason why I'm simplifying it is because we're going to need that derivative. So I get 10,000, and then I get x squared plus x plus 3 all over x squared plus 3x. And now I'm going to take that derivative, so C prime of x equals 10,000 over, so then that's going to be x squared plus 3x times the derivative, so 2x plus 1 minus x squared plus x plus 3 times the derivative, 2x plus 3 all over x squared plus 3x squared. So that's the derivative we're looking at. And what I notice here is that, okay, since the denominator squared and the only value where it would not be defined is when x equals 0, and that is not on the interval that I'm looking at from 3 to 6. Okay, so the function's continuous. Again, I'm looking right here. The function is continuous from 3 to 6 because it would only be defined when x equals 0. The same thing for the derivative. So the function is continuous and differentiable, okay? So now what's the next part of Rolle's theorem that we need? Well, let's check out what C of 3 is and C of 6 is, okay? So this is where you're gonna want to pull out your calculator, and let's go ahead and get those values, and I get 8333.333 and 8,333.333. The exact same value, right? Okay, so since c of x is continuous on 3 to 6 and differentiable on 3 to 6, and since c of 3 equals c of 6, which is 8,333.333, then Rolle's theorem guarantees a value r on the interval from 3 to 6 such that c prime of r will equal 0. All right, so now that we've stated that, let's kind of actually answer the question. We want to find that guaranteed value for r, that x value. So what I want to do is, let me grab my calculator here. I'm going to add a graph, and I'm going to put the original function in here. So that's going to be 10,000, and then I've got 1 over x plus, and then let me add in fraction x over x plus 3. And let's graph it. And let me kind of fix up my window. All right, so now that I have my window showing me some relevant information here, what I want to do here is I'm going to hit tab, and I'm going to write down, okay, I want the derivative of that original function. All right, so right here I want to graph the derivative. So I'm going to pull up a new graph, a new line to put in a function, and I'm going to select this one. So it's going to be d dx, and I want of f1, because that's where my original function is. So f1 of x, and let's go ahead and graph that. And you can see right here in pink that it graphed my original function. And so what we want to see is, where is it equal to 0 on the interval from 0 to 6. So what I'm going to do now is I'm going to go menu, analyze graph. We want to find a 0 from 0, and we want to find the 0 of that derivative, so of f4 in this case. And I'm going to just find it from 0 to 6. And you can see that it found a 0. Let me kind of bring it up here. Don't worry about the y value. Of course, calculators may not be able to get it down and simplify that to 0, but e to the negative 11th scientific notation, that's a very, very tiny number. All right, so my function, or sorry, my x value, my value for r is going to be 4.0981. Remember, it's only required that you go to 3 decimal places, but if you can go to 4, it's always better to go to 4. So 4.0981. We're going to say here that c prime of r equals 0 when r equals 4.0981. All right, and now let's look at our final question. For 3 to 9, what is the greatest cost for order and transportation? Now here we're going to be using the extreme value theorem, but you don't normally need to say, by the extreme value theorem, this thing is stated such and such, okay? So what do we need to do? Well, we need to be able to analyze all of our values. So let's see, what is c of 3 equal to? And we already have that value. That is equal to 8333.333, all right? And then the new value that we found, that where the derivative is 0, so that's a critical value. So let's see, we're gonna need c of 4.0981. All right, and that's kind of why I still have it in my calculator. So if I go to my calculator and I want to trace my first function, then all I'm going to do is, you can see that it's already blue, it's already looking at my first function. So I'm going to go 4.0981, and let's see what it gives me. So that's going to be 8,213.7. And if you could go to more decimal places, I did get more decimal places earlier. Of course, remember, just change the float and you'll be able to do that. 8,213.672. And the endpoint, the other endpoint, c of 9, and c of 9 is going to be 8,611.111. So when is the greatest cost for order and transportation? Well, the greatest cost is going to be the greatest value here. We know that there are going to be no other greater values because we don't have any other critical values in this function. So what is the largest number out of all of these? Well, that's going to be when x equals 9. So the greatest cost is when x equals 9 here. All right, and that is actually going to conclude this video. So each of these is going to usually just be one problem per one video, so you can kind of get through it at a good pace and kind of chunk it out as you need. Of course, if you didn't understand any of the reasoning behind any of the problems that we did here today, please reach out to me so I can help you with that. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.